Hello and welcome to this new video tutorial. This time around I want to show you the t-test for two means with unknown population standard deviations. This is usually called the t-test for independent samples, or there are many ways they call it at different textbooks. Different situations are called, the test is called differently, but we're talking about the same test. You have two means. You have two populations, and you want to compare the population between the population means between those two populations. So you like to make a statement about those two populations, mu1 and mu2. All right. So how you do that? You just simply do that by using sample information. You get a sample from the first population, and you get a sample from the second population. And those samples are independently gathered. If they're dependent from each other, then you wouldn't use this test. You would use a pair samples t-test or something like that. Okay, so just to make it short here, this test, many people find it hard because it requires a lot of steps, and possibly it does. So it's quite good that you have this automatic solver to make it easy for you. So essentially what you need to give the solver in order to work properly is the sample information for the first sample and the sample information here for the second sample. So what do I mean by that? Well, for the first sample, you need to give me the sample mean. You need to give me the sample standard deviation, and you need to give me the sample size. And the same for the second sample. You need to give me the sample mean of the second sample, the sample standard deviation of the second sample, and the sample size of the second sample. How do you get that? Well, a big percentage of problems you're provided with that information. They tell you the mean of the first sample is this, the standard deviation of the first sample is this, blah blah blah. Or they can give you a data set where you have a number of observations for each sample, and you can compute those the values of the sample mean, the values of the sample standard deviation, and the sample size. Sample size, just you don't have to compute it, just count how many elements you have in each sample. So okay, that's it, and then that's all you need to know. We check information, just fill out the 6 boxes. And also one tricky thing that some books teach it differently, but there's the official version, if you will, which is you need to tell the solver which type of variances do you have. You can assume you have equal variances, like it's selected here, or you can assume unequal variances. Or sometimes the problem calls for you to test for the equality of variances, in which case you have to select this. Most typically, you will want to click here, but it's usually given in the, if nothing is said, you will want to assume this. There are other strange assumptions sometimes that some old-fashioned professors, when you have a large sample size, they use a formula that has to do with assuming unequal variances, and they use the so-called conservative number of degrees of freedom. All those are approximations that are not, it's not the latest way of seeing stuff. And every recent textbook, you're going to find that for certain case of equal variances, you use a certain formula. For unequal variances, you use a certain different formula with a different number of degrees of freedom that has nothing to do with the conservative quotes degrees of freedom that some old-fashioned teachers like to teach about. So well, you just probably have to follow the cue of the sample problems. Let me show you a sample problem so you can just take a look. In this case, it says each patient of Aloha Memorial Hospital is asked to evaluate the service at the time of release. And so there's two. I'm going to skim over the reading. I'm just going to say you have two types of patients, and you have sample information for each. You have sample mean for senior citizens, and you have sample mean for other type of patient. You have the sample standard deviation for senior citizens, and you have the sample standard deviation for the other type of citizens, and you have the sample size of each. Then the question is it reasonable to conclude that the mean response time is longer for senior citizens? So is this sample coming from a population with a larger mean than this one? All right, so right away, if senior citizen is set as the first population and other as a second, clearly what you need to test is this. Is a senior population having a longer mean response time? So one is senior, two other, so that's what we want to do. And then we just test this and we put the information. Sample mean is 550 in this case, according to the problem. Sample standard deviation is 0.40. 0.40, and then the sample size is 50. Now, for the second population, other is 530, 5.30. For the other one is, let's say 30, 0.30 standard deviation, and the sample size is 100. All we need to know now is what is the significance level. So you know the confidence level is 99%. So how do you compute the significance level? It's just 100 minus 99%, which is 1%. And that is typed as 0.01. And as you can see, it doesn't say anything about the standard deviation, whether the population standard deviations are assumed to be equal or not. It does not say. So we just assume equal variances as a default option. Okay, and then what do I do now? Just click solve. And then you have a nicely typed solution with all the details, confidence interval, conclusion, decision about the hypotheses, test statistics, rejection region, critical values, all you need to know to have a complete answer. Remember, you can always take this, copy paste into your Word document or whatever you want to do with it. Observe that if I wanted to test for equality of variances before, which is actually the correct way to do it, really, because before applying any type of T statistic, you need to know whether the variances are, the population variances can be assumed to be equal or not. You could, if you want, you can test for the equality of variances. And what it does here, first, it tests for the equality of variances, and based on whether the variances are equal or not, it computes the statistic. In this case, it finds that the null hypothesis of equal variances is not rejected. So we don't have enough information to say that the variances are not equal. And it uses the formula for the equal standard deviations. Notice that this formula is called the pooled variance formula because it makes some sort of a pooled estimate of the standard error. Okay, but as far as you're concerned, you just have to fill out these boxes with information that comes directly from the problem, and then just click solve and you get your solution. Alrighty, that's it for today. See you in the next one.